This is a presentation of the workflow in the cement industry based on Architect's engineering base with a minerals and processing solution. First, you will have a short overview of the user interface, and then we are going to create a new part of the plant. On the left-hand side, you see the Engineering Base Explorer, which gives you accessibility to all the objects that are in the database, all projects, all templates, all sheets, and so on. On the right-hand side, you see Visio, which is an embedded part of Engineering Base to create sheets and all kind of reports. Here we see an example plant with silos, belt conveyors, and all other equipment. And it's not just a drawing, it's not just drawing, there are information behind. For example, if you navigate to this belt conveyor, Engineering Base switches to the functional view where you can see the complete plant structure and also the structure which is below the machine. For example, here you see that you have drift switches, rope switches, and also a drive. And by selecting one part of that machine, you will see all the devices that are necessary to make it run. In one part of the plant structure, we can see that there are no details available at the moment. This is our chance to improve. It is quite easy to create a new part of a plant on a blank sheet, as we do now. We don't have to draw all the details manually. For this, we can use the powerful circuit components, where a lot of machines and components are prepared. For example, to design a new mill, which is one of the most complex machines, we just need to select it from the stencil and use the right mouse key to place the complete mill on the sheet. After a few seconds, the dialog will pop up where we can select the complete plant structure to be sure that the machines are sorted in the right way. For this, we have access to the complete plant structure, and this way it's quite easy to select it with a few clicks. And then you can see the complete definition on the sheet. The next thing is that we just might complete it with a belt conveyor. We just need to do it in the same way, using the right mouse key, drag and drop it onto the sheet. And we also can select its functional structure. In this way we use a second one, and we do the same with another belt conveyor. So here you can see that you can reuse the existing templates very easy and as often as you need. And then it's quite easy just to connect those components by using the connector tool. In a very few clicks you can complete your flow sheet. Let's have a look what happened. So in the sheet we get a complete designation of all equipment, but if you look here in the details, you can see that they are not unique at the moment because they used the same template. But this is not a big deal to change. We just need to navigate to have an overview of the complete plant structure. And here, by this exclamation mark, you can see that this information is not unique at the moment. Also, with the mill, you have all the different machines, and it's quite easy to select just the 3 machine combinations, and then by using the breakup component feature to make it unit and to sort it in the right way for your plant structure. And in the same moment you can see that all the equipment is unique now, and from this point on we are sure that all the information is right. You saw that we created a very complex plant structure with just a few clicks. It's also possible to work in lists. So It's just one click to open a new worksheet like in Excel to get a complete list of mechanical equipment. You can see this in that kind of view. There's a new task and you will have a complete list of all the machines that are in that part of the plant. All the lubrication and fans and flaps, or also the belt conveyor and the spillage conveyors of that 3 equipment is in the list now. This is a complete list of that plant structure, but it's also possible to have a filtered list, for example, only belt conveyors. But this is not only a list. It's called worksheet because you really can work in that. If you might see some attributes listed here that will be shown in the graphic as well, it is your chance to change this in a very short time and very comfortable. So you just need to enter the values in here and you can see how the information is put into the graphics automatically without doing anything more. So this is the example of that all the objects in the graphics are associated to the object model and all the information will be like synchronized, but it is really exactly the same record in the database, unique information. So here you can see that all the information that we put in are displayed in the graphics. All the information are stored in the database and this enables us to display this information in different ways, not only graphics and lists, but also data sheets to a particular machine or group of machines. So it's also quite easy to create these data sheets with a few clicks. We don't have to create data sheets for each particular machine. So we go to this part of the plant and then we create the data sheets for all these machines in one click. And 2 seconds later they are available. We don't have to search for the documents because all the documents are associated to the machines in a special document structure, and it's quite easy just to open it with Visio and the document will be opened. If we arrange all, we can see the flow sheet and also the content of the data sheet here side by side, and it's quite easy just to do modifications. In that case, if we do something in here and by clicking the OK button, all the information is transported to all representations in all documents immediately and without any data loss, without any evaluation, without any post-processing. Let's have a closer look on the next level of information. If we go to our plant structure, we can open the next detail level for loads and measurements. This is also just a filtered view on the same data set. We can have a look at the list of all drives in that plant. For example, the belt conveyor, we just need to navigate to it and then we see that there is no detail information available at the moment. But we're going to change this very soon. For this case, we can work with templates. Working with templates makes the engineering very fast and easy and comfortable. The templates, also called typicals, contain all the information belonging to a tag. They can contain material information, device information, also graphics and signal information for the automation. We can select a typical quite easy right in the worksheet. For example, for the attribute of typical, we can select this direct from a typical project, and in this case we can select one of this. In that case, for example, here we have a preview of the graphic and the list of all devices that might be copied in one step. And then we can go on to copy it with the autofill feature like in Excel. And for the variation of that, we can just select another one, maybe a smaller, and we can copy this information in the same way. It's also possible to decide in which location the devices should be stored automatically. The typicals can be prepared with, let's say, a kind of placeholder for location information, and you can decide to which particular information of your structure the devices will be merged. And this structure can be different from project to project. Here we use the same autofill feature as for the typicals. And here we select that we want to place the devices in that structure using the autofill feature, and the location for the plant for the field devices should be directly here. So now we defined all information that are necessary for the typicals to be copied and merged into the project that we are working in. The typicals will be copied in just a few seconds. For this we can run a very powerful tool called Typical Manager that analyzes the information below and gives an overview of the tags and the machines we defined. So for example, we see the list of machines, but it's quite easy to type in a filter to get a filtered view in here as well. So we just see here all the machines, the loads, and also the merged locations that we saw. At the moment we don't have any devices in here, but we're going to change it. We just select this equipment, and then we just need to click the OK button, that all the templates will be copied and all the copies will be unique in the database. So in a very few seconds we get a list of all required signals for the automation. We will get all the devices with all the materials in a very short time. So this is what we did here, and then we can go on. You will see the result in the list pane, for example, of related equipment. You will see all the devices, all wires in different locations. This is the result of our merging. As you understand, we got a list of new devices with this feature, which can be displayed with a worksheet as well. We just need to open a worksheet for instrumentation, and then we get a list of all the devices that will be necessary for all these machines. Let's have a look at the document structure, and we can see that we got a new folder with a complete plant structure, and for each machine we got a list of all sheets that are copied to that. And it is quite easy to resort this structure just by using drag and drop, for example, into another folder, and then we have a complete structure matching to the different information. Now it's time to combine the new information with the already existing information. For example, electrical power supply. For this we can have a look of what is available at the moment. We can see here a document which shows a single line diagram of the power supply. It also can be used for the documentation of high voltage, middle range voltage, and also low voltage. So in all phases of the power supply you can have several documents and also drawing styles. Here we have an overview of an MCC module. This gives an overview of what motor is connected to one MCC module. If you want a more detailed view on the MCC module, you can open another sheet that shows that this cabinet contains a number of MCC modules but they are not used at the moment because there is no plant designation in. To decide which of these MCCs should be used by the new motors that we copied right now, it is quite easy to select it, because we just need to go to the area where all these devices are merged into. And here we can run a tool called Merge Device Wizard. The Merge Device Wizard will give you an overview of devices that are available at the moment and where they can be associated to. And by selecting the ones, we can decide where they should be merged. And in that moment you see that they are used by this. The list of these devices will be reduced. You can select another one, or you can select both on this side and then using this feature to associate it in one step. So now we have done the complete merging of the devices inside the cabinet or inside the MCCs. And now it's time to have a look at the cabling in the field. In the circuit diagrams we have the information that a motor is connected to the MCC with a cable. And in the circuit diagram we don't have any length information, but this is very important for the cabling. So we have to find a way to combine the logical connection from the circuit diagram with the physical situation in the plant. And for this we have a general diagram which was created in another tool, and this was imported via an engineering base DXF or DWG import feature. Based on this imported drawing, we can add information from the logics of engineering base, and here we see that we have the loads, the drives of the machines, and the lines in orange colors are the cable trays. So this is a kind of the physical structure of cablings. If we navigate to it, we can see that it is collected in a topology folder where all the segments of the cable trays are in. If we using a cable list to show the routing, we can see that all the cables are in automatically by the data model of engineering base, but the length is missing at the moment. But it is also quite an easy thing to run a feature called route wires and cables into bundles, and by using the physical structure we can get the right routings for the cables and collecting the right length. So at the end we designed a new part of the plant with a mill and belt conveyors, and we created data sheets and lists, reports, circuit diagrams, and at the end we also created the routing for the cables that we get the necessary length of the cables. Thank you.